Okay? So what you made on your wax paper is a parabola. And you made it using the two key parts to a parabola. I should tape this up so that we can see it. The two key parts to the parabola that you used was the focus and the directrix. Math speak here now. We're going to get a little math speak action in here today. Math speak is going to tell me that the definition of a parabola is all points equidistant from a point called the focus. So this dot that you put in the middle, that is your focus. Okay? That dot's your focus. And a line called the directrix. This line down here is called the directrix. Okay? So the parabola, the red parabola, is all points equidistant from the blue dot and the black line. Okay? Now, you've seen parabolas before. You saw them in Algebra 1. You saw them in Algebra 2. Okay? But you've only seen half of the parabolas. We only did in Algebra 1 and Algebra 2, we only did parabolas that opened up or parabolas that opened down. We're going to add in today parabolas that open left and parabolas that open right. Okay? So we're going to get all of the different kinds of parabolas. Okay? So, the focus is a point located inside the parabola on something called the axis of symmetry. The axis of symmetry is the line that runs through the focus and is perpendicular to the directrix. Okay? That is the axis of symmetry. We shorten it up to AOS. Okay? Normally, we would call that the folding line. Okay? It's the line that you can fold the parabola on and you get the same thing. But because we did a bunch of folding with your wax paper, I'm going to call it the mirror line today. Okay? If I were to stick a mirror on that line, okay, we would get a mirror image on the other side. Okay? The directrix is a line outside of the parabola, and it's perpendicular to the axis of symmetry. Now, normally when you draw the axis of symmetry and the directrix, we draw them in a dashed line, which is why on this slide I had it as a dashed line. Okay? Because the parabola is going to go somewhere through there. Okay? The parabola would be the solid line, directrix and axis of symmetry would be dashed. Okay? Okay? So, we have to talk here, I don't know why that didn't erase. We have to talk a little bit about the relationship between all of those points. Okay? Located at the intersection of the axis of symmetry and the actual parabola is something called the vertex. Okay? So this point right here is called the vertex. Okay? The vertex is on the parabola. The focus is inside, the directrix is outside. So you've got an inside point, an on point, and an outside line. Okay? In math, we call the distance from the focus, to the vertex, we call that distance P. Since we said the definition of a parabola is all points that are equidistant from a point and a line, okay? Well, this point, this red dot is on my parabola, so if that distance is P, that's the distance to the point, then the distance to the line would also have to be P. Okay? So P is the distance from the vertex to the focus and from the vertex to the directrix. Okay? When we go using this, and when you start seeing the equations of parabolas, that is actually going to be a number out in front of the non-squared variable, and it's going to be 4p in the equation. Okay? But p is that distance. You'll see it as 4p in the equation. You'll use it as just p on a graph. Okay? One, two, three, four. So that's the 5 chunks of a parabola. You have the actual parabola. You have the focus. You have the vertex. Then you have the 2 lines, the directrix and the axis of symmetry. Okay? And those lines are perpendicular. Okay? So, when you're dealing with parabolas, the first thing that you have to determine is you have to determine which way your parabola is going to open. Back in Algebra 1 and Algebra 2, we looked at the number in front of the squared term. If it was positive, it opens up. If it was negative, it opens down. We called it that A value. Well, now we can't just do that because we have 2 other kinds of parabolas. So there are 2 things that you have to look at when you are trying to determine the direction of opening. The first thing you have to look at is you have to determine which variable is squared. Okay? If x is squared, it opens up or it opens down. If y is squared, it's either going to open left or right. Okay? So that's the first thing you look for. You look for which variable is squared. If x is squared, it's up or down. If y is squared, it's left or right. Okay? Then you look at this number. That number is not only 4p, but it's the coefficient on the non-squared variable. That's that important number. So you're first looking at which variable is squared. Then you're looking at which variable is not squared's coefficient. If it's positive, it's going to open up or to the right, the positive directions. Okay? On a regular XY coordinate grid, up is positive, down is negative, right is positive, left is negative. Right? So the two positive directions are up and right. So if that number in front of the non-squared variable is positive, it's going to open up or right, depending upon which one's squared. If x is squared and it's positive, it's going to open up. If y is squared and it's positive, it's going to open right. If it's negative, then it's going to open in the negative directions. Okay? So it's going to be down or left. Okay? So here's 4 examples of that. See if I can get them. There they are. Okay? So if x is squared and 4p is positive, so we got a positive 8 going on there, that's going to open up. Because we have x squared and 4p is positive. Here's my 2 looks. I have x squared and 4p is negative. I'm opening down. Y here is squared. 4p is positive. That's going to open to the right. Y squared and 4p is negative, opens left. Okay? So what I would like you to do now is I would like you to do 2 things on those 2 equations. First, I would like you to determine which way they open. Which way does the parabola open in those 2 equations? And second, I would like you to figure out what the value of p is on those 2 equations. So, first one. Which way does it open? Down? Does everybody agree with down? Somebody justify for me why it opens down. Go ahead. It's a what? It's an x squared? Or, oh, I see what you're saying. So you're saying just because it's just y? Okay. Because only one of them's squared. So if it's just y, then it would be x squared. Okay, I'm with you. Because like Ryan behind it was thinking the x squared part, which was what Ryan and I were on the same wavelength. Now I see what you're saying. Okay, and? Okay. So that's down. I'm with you. Okay, so my 2 checks are, here's my x variable, it's being squared. So that's up or down. This number in front of the non-squared is negative, so it opens down. Okay? What's the value of p then? Sam? 5. Because it's a distance, p is going to be positive, so p is 5. Really, what I did here was I did 4p equals negative 20 and divided both sides by 4, and I get p equals negative 5. But because we defined p as a distance, we just made it positive. Okay? Second one. Up, down, left, or right.
which would tell us that it's either going left or right.
Okay.
And then the coefficient for x is positive.
So that just leaves me with right. Yep. Okay. So I got y, it's squared, that makes it left or right. And the number, the coefficient on my x is positive, that just makes it be right. Okay. What's p equal to in this case? P in this case. 2, yeah, because what's the 4p is that 8 number, right? That number right here. So 4p is 8. So p is 2. You can absolute value it, it's still 2. Okay? So that's the first thing that you've got to determine. You've got to determine the direction of opening and what p is. Okay? The second thing that you're going to have to identify is you're going to have to identify where that vertex point is. Now, the standard form of a parabola is x minus h, quantity squared, equals 4p times y minus k for all up and down parabolas. Okay? Actually, we could even go plus or minus 4p there. Okay? Depending, because then it goes up and down. Or, for left and right ones, it's going to be y minus k, quantity squared, equals plus or minus 4p times x minus h. Okay? So for either one of those two forms, the vertex is at the point h, comma, k. And I left you a little note at the top of the page that says, remember, when you're dealing with something inside a set of parentheses, that you need to think oppositely. So down here on this one, my vertex is going to be at, I see negative 3, but it's inside a set of parentheses, so I'm going to think oppositely, and it's going to be positive 3. I see positive 1, but it's inside a set of parentheses, so I think oppositely, and it's going to be negative 1. So the vertex of that parabola is at 3, comma, negative 1. So this point, this vertex point, is my starting point. Okay? And then from that, I can say, well, in this case, p is equal to 3. So this is a down parabola, so I would go down 3 and I would get my focus point. I would go up 3 and I would find my directrix line. Okay? Very quickly, what's the middle vertex? We got it right? 1, comma 0? Yep. Just wait. We can do it quickly. It'll take us 10 seconds. What's the vertex of the third one? Negative 2, comma, negative 7. Because the h part is attached to the x, or comes along with the x, and the k part comes along with the y. So you got to be a little careful when you're talking about what's your h and what's your k. H goes with x, k goes with y.